Hello, welcome. This is day 5, probability 2. So today we are going to discuss about some of the continuous probability distribution, right? Earlier we have already said about Gaussian distribution. Today let's start with 5 more distribution, continuous distribution, and I am only going to share you about its formula. Later on we will be discussing its application, so be with me. I know it is little boring, but yeah, it is important. Number one is student t distribution. Okay, so whenever there is some outliers, okay, so we need some type of distribution which may not be affected by the outliers. uh, if we see the Gaussian distribution, it mainly gets affected when there is some of the outliers, but uh, all the distribution who have long tail or heavy tail, those distributions are not affected, and student t distribution is one of the heavy tail distribution, right? So it is represented as t x mu sigma square v. Okay, here mu is mean, but sigma square is not standard deviation, right? Variance. It is scale parameter. Okay, v is degree of freedom. This is inversely proportional to 1 plus 1 by v x minus mu by sigma whole square to the power minus v plus 1 v plus 1, okay, by 2. So yeah, it's mean is mu, mode is mu, and variance is equals to v sigma square by v minus 2. Okay, let's move to second distribution, that is Laplace distribution. Laplace distribution, it is also a long tail distribution, and we represent Laplace x given mu and b. Definition is 1 by 2b, this is b, exponential minus 1 x minus mu by b. Okay, here the mean is mu, mode is again mu, and variance is 2b square. Okay, uh, third, gamma distribution. Gamma distribution. Okay, so what is this? It is given by GA T shape is equals to A, rate is equals to B, and the formula is B to the power A by T A minus 1 e to the power minus T B. Okay, where gamma of lambda is given by 0 to infinity uh, e to the sorry, u x to the power minus 1 e minus 1 du. Okay, here mean equals to a by b, mode equals to a minus 1 by b, and variance equals to a by b square. Now fourth one, that is beta distribution. Okay, so it is given by beta x given a and b as a parameter is equals to 1 by b a b x a to the power minus 1 1 minus x b b minus 1. Okay, here b a b by definition is gamma b beta this one. Okay, I'm actually forgetting its name, what it really called by. So yeah, but you may remember this. Mm, okay, if I get its name, I will share you in the next video. Fifth is Pareto distribution. Okay, it is given by, see, this is also a long tail or heavy tail distribution. Okay, so if there is some outliers, then this distribution will be not affected by those outliers. uh, Pareto, given k and m, k m to the power k x minus k plus 1 identity function x more than equals to m. Okay, so that's all for continuous distribution. Let's move to our next topic, that is joint probability distribution. Okay, so here more than one distribution which are related to each other or may not be related to each other, we consider those probability distribution. In other words, there is not only one distribution but more than one distribution is possible. Okay, so the first concept is covariance. Covariance. Okay, so between x and y is given by covariance of x comma y, and by definition it is expectation of x minus expectation of x uh, multiplied by y minus expectation of y. Okay, and if you evaluate it, we will get expectation of xy minus expectation of x expectation of y. Okay, similarly covariance of vector x where vector where vector x is nothing but x1 x2 xd. We are assuming the vector x is of d dimensional, and this each of the x is a random variable. So this gives variance of x1, covariance of x1, x2, covariance of x1, xd, covariance of x2, x1, variance of x2. Okay, and the last will be row will be xd x1, variance of xd. Okay, now um, let's move to next topic, and that is correlation coefficient. Okay, so it is given by between suppose x and y is by definition covariance of x and covariance of y by variance of x variance of y. So this correlation coefficient is mainly used to normalize the covariance, because the covariance may uh, go to, it is not at all limited, but it can go to any number. Okay, so to limit it within -1 to 1, we use this formula. So last concept is correlation matrix. It is given by R, and this is nothing but correlation of x1, x2, uh, same as above. Wherever uh, there was suppose variance or covariance, you can replace this by correlation, right? So okay, correlation of x1, x2, similarly, and this will be correlation matrix. Finally, let's move to our last topic before we close for today, that is multivariate Gaussian distribution. Okay, so I will be only sharing the formula for this, and as we move we may fill the requirement and know more about application. Okay, so it is given by vector x given vector mu and vector sigma. By definition, it is 1 by 2 pi d by 2 vector sigma to the power half, and this is determinant exponential minus half vector x minus vector mu transpose sigma to the power -1. Okay, and vector x minus vector mu, this term. So where mu is nothing but expectation of this vector, this will be a d-dimensional vector, and vector sigma is nothing but covariance of vector x, which will be D cross D matrix. And finally, okay, this thing we use as sigma to the power minus 1 and may replace some of the terms, like here we can replace as per requirement. uh, Now you can ignore this term and make focus only on this formula. Okay, that's all for today. Meet you tomorrow with some more concept about probability. Bye.